I'm back for tutorial number 3. And who would have thunk my tutorials got the attention of some people. Well, a few Modalys people. It's not like it's a cat video, you know. So very niche still, but shout out to a user called Theo who gave me a very good hint about the Max library. And also shout out to Jean Lochard who wrote a comment. I was surprised. Modalys royalty from the IRCAM Supreme and the IRCAM itself even reached out to me. They're gonna post these tutorials. I hope they know what they're doing here. And so in the spirit of rejoicement, today let's blow in the tube of celebration. Yes, that's right. We're gonna make a tube and blow in it today. I think I'm gonna make 2 tube blow tutorials. One normal and like standard, and one with a hole. And there's several objects you can use as reed. So I'm thinking of showing 2 of those. So let's get right to it. The principle is simple. The tube in Modalys, the tube object, there are several. There is open tube, so open on both sides, closed, and there is open and closed. So closed on one side and open on the other side. And what we're going to use as an exciter is again a 2-mass object. Today, for once, we're going to use a mono 2-mass object because it only needs to move in one direction. And actually, Jean Lochard, about my first tutorial, pointed out that if you want to save CPU, which can really be the case especially in Max, and you only need to pluck a string, it's of course much better for CPU usage to just use the monostring and the monomass. But it's the same principle, you know? So we have a tube, and the tube doesn't have material as of itself. So it's, as far as I understood, if you go to the reference and you go to the closed open tube, which is mostly used, they write it's a column of air. So you can't make a tube out of diamond or out of wood. It's rather that you control the air elasticity inside of it and the air density, and of course the radius if it's a pure cube or if it's a cone or something like that, and then of course, like always, frequency loss and constant loss. And what we are doing is that we are going to use as I already said, the 2-mass object as a reed, which is going to be connected to the beginning of the tube. And we're going to have a listener at the end, and that's pretty much it. So let's get right into it. We're going to make a new buffer and make the header. As always, I will make bookmarks, but if you really want to, the understanding part of the Modalys, I usually explain in this first part. So header will be new, and just to be super safe, in package. Bugs have made me very cautious. And we're going to make the objects. So we're going to make the reed first, and the reed, or the 2-mass object, needs to have these properties of a traditional reed. It needs some values or parameters which are differing from the default values. And where you can find those is actually in the reed connection documentation. So here we go. If we scroll down a little bit, we can also see that you can use the mono 2-mass. You could also use a B2-mass, doesn't matter, just CPU wise. But we also could use a harmonic oscillator or a rectangular plate. I think I'm gonna try this on the next tutorial. But let's start with the mono 2-mass. They even explain why, if you are into maths and all kinds of physical stuff, understanding. So we're gonna set Q, my reed, make object mono 2-mass, and we need a very small mass, 0.000002. And a large mass will be the same, so it doesn't matter which way around. Then we need a stiffness 0 at 200. The constant loss 0 at 60. And the frequency loss 0 at 260. Actually, I like this the other way around. So I'm gonna, because usually in the objects it's also the other way around. So I'm gonna just do this, close it up, and that's our read. I could actually write make read, then make tube. So set q, my tube, we're gonna call it, and make the object close. I'm gonna use the closed open tube. And now we are gonna look into what we can write in here. Close up tube. So we have the modes. I'm gonna go higher than 20. That seems awfully small. I'm gonna go 100. But else, for now, I'm gonna let it be at length, at the normal thing. The tuning parameter, there is only length. There is nothing else you can tune the tube with. Elasticity 0.0000721. There. And the air density 1.2. The radius 0 is 0.01. And here the radius 1 is also 0.01. Frequency loss is 1. And constant loss is also 1. We can set the pitch if we already want to. Set pitch, my tube, it's through length, and let's set it to 80 Hertz. There we go. So that are our two objects which we need to interact. So now next we need the axes. As always, we have the hang of it now. Make axes. So what we need now is two axes on the mono to mass. Not because we're going to move it, or yeah, we are not going to move this, but we need to block it on one side, and the other thing will move, but through the read connection. You will see what I mean, hopefully. So we have two things. I will call it set q my read base. So as in a clarinet, the one side of the reed is blocked, right? So that's what we need here. So that's what we need this axis for. So I'm gonna make axis, and it's described here, as you can see. Make axis my read. Oops, I forgot the bracket there. And we're gonna do the same as here, const 0. And as it's a mono 2 mass, there is only trans 0 there. Next, we are gonna have the other, so set q my read tip. That's the part of the read that is gonna vibrate through the read connection. So make axis my read. It's going to be at the other end, so const 1 and trans 0. And next we need two axes on the tube itself. So one where the read connects, so that where the reed is blowing in, and that's at the very beginning of the tube, right? So set Q my tube blown in, I'm gonna call it, and that's make axis my tube const, or I can just write 0, right? Okay, and the length parameter is where I put it. And for the output, my tube listener, I will make the axis on my tube, let's say it's 0.8 or something, and it's also length. That's the parameter that counts for tube. Okay, here we have our axes. Now it's time to make the connections. So make connections. So one, we need to block this reed base because of a monotone mass. Both both masses can move anytime. It's not like they are fixed in any way. So we are gonna make connection. I'm gonna again use this position right here, this position. So it's gonna be my reed make connection position. My reed base is gonna be blocked through a constant at 0. Done. And the next connection is the reed connection. And believe you me, the reed connection is a tricky one in this documentation. I needed some time to figure this out. We make the connection. And then it tells me here that the name is reed. That's so far so good. But then the examples and what I see here differ. And the examples work, and if I put it in like in this documentation, it doesn't. What I mean is, they say I should first put the axis on the object that will be used as a reed. So this would be my reed tip, and then as a second, the tube axis. But it's the other way around. I had some frustrating times finding this out. It's first my tube blown in, and then my reed tip. These two are connected like that. And the initial position, they write it here, is around 1 millimeter, so that would be 0.001, because that value is in meters. And then they write that there's the air pressure, the air density, the reed area, the aperture length. What I found out is that in most examples I saw, there was directly just this number written in. So it looked like that, const 2.76 E minus 4, right? Oh, Modalys, error, read console. Workspace loaded. No, that's the wrong console. Here, while creating a read connection could not chorus arguments. Oh, I'm sorry. I'm very sorry. I, of course, forgot the air pressure envelope. That's the breath envelope. I'm going to create an envelope, which is then going to... So if I evaluate now, he's going to complain, right? Breath envelope is unbound. But what I wanted to come back to is that this is the value I saw here and nothing else. And we are going to see later in OpenMusic that this actually coexists somehow. So I'm going to come back to that. Now let's make the envelope. We need to make the envelope here. So that's a controller envelope. So we are going to set Q breath envelope, and this is gonna make controller envelope 1 dimension. So we're gonna breathe in, and in the read connection, they write that the typical values in the pressure of the air is between 0 and 50,000 Pascal. I'm gonna go lower than that, so we start at 0 pressure. We go in, let's say 0.5 seconds up to, let's say 400 Pascal. Then let's go louder, even 2.5 maybe to 1000. And let's go then at 4 seconds back to 0. Okay, so now it should work. Yeah, no mistakes in the console now. Yeah, so I'm a bit confused with this value, but let's continue. So now we just need the output. Output and synthesize. So make point output. I could go back just for good measure to the documentation here. We found out yesterday that for somehow this scalar mode, this scalar thing doesn't work. At least it didn't work yesterday, so I'm not going to try anymore today. My tube listener is the axis, and now we just need to run it for a few seconds, let's say 5 seconds, and then to play the sound. Let's hear it. Okay, that sounds, well, it sounds like crap, but it still sounds like a tube, like a very, very shitty clarinet. So we should change a few things around. So now starts the fun part in Modalys. So let's see what happens if I make maybe a little bit a coney shape. So here is 0.15 at the end. Let's make it deep. I like deep frequencies. If you haven't noticed until now, I don't know what you have been paying attention to. Let's raise the air density. Let's listen to this. Oh, I like that. Let's make that longer. Let's make 4.5 seconds and 6, and then we need this to run for 7. Oh, a dinosaur just farted. Well, anyway, that's the tube. The closed open tube getting played, and now it's time to do the same in OpenMusic. So let's open a new patch. 03 blown tube. Okay. We're gonna open this here, and we're gonna try to rebuild exactly what we have here. I'm gonna just be sure to load the library. I think it's already loaded. Oh no, it wasn't. Okay, so here we go. So this time we have an Emless mono to mass with some special, so frequency constant loss. So constant loss is 60. If I hover over it, I don't get why they called it constant loss 1 here and not 0. Frequency, and also stiffness 1. Maybe a typo, I don't know. Because in Max, if I remember right, it's called 0 again. Okay. Anyway, that's not drama, no drama here. Large mass is 0.0 0.00002, and the small mass is 0.000002. So that's our mono 2 mass. Now let's make the closed open tube and see what we can do with this. So what we said, it's length and it's 30 Hertz. Then the modes are 100. The length is going to change anyway. The air elasticity, I'm just for good measure, I'm going to put in the same number as we have in the script. 721. Then the air density is 1.8. We rose that. I have no idea if in the pre-start time air density was higher. I know it was different, the atmosphere was different, but well, 1.5, and frequency loss and constant loss are the same. Okay, next step, business as usual, access. We need some accesses, so 2 here, 2 here. The object comes in here and here and here and here. So the blocked base, the read base, is at constant 0 and is trans 0. The 2 mass is at 1. So that's the read tip, and it's also trans 0. The connection here is 0, but it's long, and here it's 0.8, what we typed in, and it's also the length. Why it's called long and not length? Who knows? Maybe another programmer at work, but I can still get it. Okay. Now for the blocked read, we need the position connection, which is gonna control this. And this time we don't need an envelope. We just need to type in that it stays at 0. It's blocked. No way out. Mless read. So let's see if it's the other way around here as well. But I don't think so. So if I hover over it, control, access tube first. Yes, it is. Access tube first and then access read. Okay, so it's the other way around. This comes here first, then the access read, then the position, right? Read separation, so 0.001. Next we have the air pressure or breath. Okay, that's gonna be the envelope. And here we have the read area. Okay, so it's the read area, and that's what they wrote in, let's go back, read connection, aperture, no, here, read area, the surface area of the read. But here they talk about aperture length. I'm really a little bit confused by this, because in the document or in the examples, I rather found that number, which seems to indicate the aperture length, but I'm confused. Maybe it's me. Maybe I'm doing something wrong. Please let me know in the comments. We all learn. I'm gonna put in this anyway, -4. Okay, and now we are gonna build our controller. So we need an mless envelope that goes in to be the breath controller, and we are gonna control it as usual with a breakpoint function. And this is gonna go in here. now we just need to type in this envelope. So we started 0, went to 0.5 seconds, then to 4.5 seconds, then to 6. Close the bracket. And the values we had were 0, 400, 1000, 0. Little T-Rex having a good time. 2. I'm gonna put in 2 here. Yeah, that seems right. We need the mlis point output here. And now it goes over to synthesizing. So synthesize, we need the mlis run here, and we need the mlis new object, and I still don't know what these two are, but I know how to create the extra inputs with option right. So now we connect all this. Okay, this read the output, and the run here we set 7 seconds. We make the sound object and see if this works. Okay. Haha, good. That sounds very relieving. Okay, so that's this. So it's time, I guess, for Max. So let's move over to Max. Let's make a new patch, and the whole thing around is really fast done. We need a load bang again. We need at the end a mlis script. We need the mother of all objects in Modalys, which is Modalys. There. We need an easy DAC, and before that a live.gain, so that we get our sound. So there we go. Okay, so we are gonna make our object again. I'm gonna make a mlis mono 2 mass this time at name. I usually always put a name because I have seen some example patches where just because one object had no declared name, for some reason it didn't work. So I always put a name. So this is my read. And now comes a shout out to Theo, who had a very, very good, I can't believe I didn't think of that before myself, but the attributes that you can write in here are all written in the inspector. Of course they are. I'm such an idiot. But here we go. So we can basically type in everything here, which I'm gonna do this time. Here, so the constant loss is 60. The frequency loss is at 260. The large mass is 0.000002. The small mass as well, 0.000002. The stiffness is around 200. There's no pitch, mass, doesn't mean anything, so the rest is cool. Good. And the initial in and out are also right. We're gonna block the in, I guess, with a mlis. We can also do that already. Position. This dot position at position 0 just to block it, and here at name position pos. That should be okay. So that's how we block it, I guess. And then the next thing is we need the read connection. mlist.read at name read con. If you can now go here, well, here there are again all these. I just don't get this documentation. I'm really confused. Maybe it's just me. I can be an idiot sometimes. But now suddenly there are all these parameters here in Max, and they're not in OpenMusic, and they somehow are the order of which parameter is where is also unclear in Lisp. So maybe somebody knows the secret of this whole thing. But anyway, let's go back to the patch and let's try to find the right thing. So in the if I look at the OpenMusic patch, this is the read area. So I guess I'm just gonna put it in the read area. So the read area is gonna be 0.000276, right? The air pressure we are gonna control from outside. The air density we can already put up to be really unhealthy. The initial position is right, and the length I don't know. Okay, let's do the next object. So the next object is mlist.closed open tube. Name my tube there, and here as well we are gonna for once do it here. So the initial position I guess will be 0. The initial out position will be 0.8. The air density, oh, I wrote it wrong. Okay, I'm gonna leave it here at 1.2 at the read connection. Else I don't know. You can try this out and mess with the parameters, obviously. But I'm gonna go like as close to what I have here as possible for starting. The length is gonna be the thing. The modes are gonna be 100. The pitch is gonna be 30. The radius 0.1. I had 0.15 here at the end when I was happy kind of with the sound. Now we just need the point output at name out. Okay, and all this gets connected to the script. Just to be able to see everything, I'm again gonna use this ctrl list here and the print object here, and just see if everything works. Yeah, okay, everything is coming in, and now we are gonna do the breath controller. So what we need to control here is not the position here as we did until now with the bow and the plucking, but the read itself. So the read con air pressure. Read con at air pressure $1. I feel like I will try something out. I will not build exactly that envelope. You can do it, but I'm gonna attach a slider. There, And the slider is gonna go from 0 to, let's say 2000. I'm curious. Okay, so let's see. Ah, so it's very soft. I probably need to normalize. I'll normalize. Normalize 0.8, let's say. Wow, that's nice. I like these non-linear responses from these tubes. But the strange thing is that at some value it seems to completely stop sounding. I don't know why. And what I also noticed is we're going to try to pitch it. So let's say we have a key slider and a traditional M to F, so to frequency, and are going to set message my tube at pitch $1. So I'm going to put a C. Okay, let's see. If I go up fast enough, let's go. Cool. That's out of tune. Am I the only one to hear this, that this is not a clear octave? That's almost C sharp. That's an A. That's not a B flat. That's an A. So there's something strange with the tuning. I'm not sure if it's deliberate, like in a sense of microtonal possibilities, but no, it doesn't make sense that I would send in a precise frequency and that it would not be precisely calculated here. So the read connection for me is still a little bit mysterious thing, but it has some very powerful stuff. So I really like these deep frequencies. When they come. So on this note, let's end the somber flatulence. Okay, so I hope you enjoyed and see you around.